Good afternoon, Doctor. We are from Session 1, Group 6. Today, we will present our chemical engineering thermodynamic project with a topic is flash separator design for ethane and propane mixture. Here are our group members, Thomas, Chu Chenjing, Sean, and Teo Yu Kai. So now is the introduction for the flash distillation. For distillation, it is a single-stage separation process where a liquid mixture is partially vaporized by a pressure reduction, resulting in a vapor and liquid phase that are then separated. And then for flash, it is a rapid vaporization, which as the vaporization is very fast. In our project, we will apply the Love's law for our calculation. This is because our project is a two-component system, and Love's law can be used to calculate the K value for two-component system, which is Ki will equals to Yi over Si, and it's also equals to P saturated over P. And the vapor fraction V can be found by solving an equation derived from the material balance and Love's law, and the liquid Si and vapor Yi composition can be done to be calculated. So the objective for our project is we can know the process and composition condition. For example, we can review the process and typical process condition, which are like the overall composition, operating pressures, and temperatures for separating the mixtures. Besides that, we also can be assuming that the reaction mixture is an ideal gas solution. Besides that, we also can know the flash calculation. For example, we will calculate the more of liquid, more vapor, liquid phase, more friction, and vapor phase, more friction.
So, Senching, I will be presenting about the calculation part. Our composition mainly consists of 90% of ethane and 80% of CH of propane. And since table B2 in our textbook, in the table B2, we don't have these two components to calculate our Antoine equation. So we are using the Felder textbook to find the latent heat of vapor from table B1, and also the latent heat of vapor and the boiling point or for ethane and propane. And then by using the Redact method, we can have the formula to find P saturation for these two chemicals. Then we are assuming that the reaction mixture is an ideal solution at 25 degrees Celsius and 180 m. And for ethane, the boiling point is negative 88.6 degrees Celsius. And then the latent heat of vapor at this boiling point at 180 m is 14.72 kJ per mole. For propane, the boiling point for propane is negative 42.07 degrees Celsius, and the latent heat of vapor at this temperature at 1 atm is 18.77 kg per mole. So the flash distillation is actually a cryogenic flash distillation, which means this process occurs at a very low temperature. Since we want the flash can separate out liquid and vapor base, so we have to set our temperature at negative 50 degrees Celsius. And we set 3 atm because we want to put the P pressure given is in between the saturation pressure and the bubble point. So if we put 25 degrees Celsius, the whole component will be vaporized and no separation is possible as they all the output is in vapor. So if we put the 30 degrees Celsius, then we can maintain both liquid and vapor phases and enable effective separation in the two-phase system. So let's start with the calculation. We are using the Redact formula, which is P1 over P2 equals to absolute power HB over R times the reciprocal of T2 and minus T1. And then we can get our saturation pressure of ethane at negative 50 degrees Celsius and 3 atm is 15.77 atm. And after we convert it to the kPa is 5 bar. And then for propane, uh, we can get that the saturation pressure for propane is 214.8102 kPa. So that would be my part.
Okay, next we proceed to the calculation of the bubble ratio, which the formula is given by the molar friction of the substance in the mixture times its pressure saturated ratio. And finally, we get the bubble ratio is 491.42 kilopascal. Okay, next we calculate the dew point ratio of the mixture, which the formula is given by 1 over dew point ratio of the mixture equals to 1 over saturated pressure of the sustain 1 plus 1 over saturated pressure of the sustain 2. And we get the dew point ratio is 189.35 kilopascal. And furthermore, the distillation pressure is 3 kilopascal, 3 atn, which is between the dew point pressure and the bubble point pressure. This means that the system is possible to distillate. Okay, since the mixture is possible to distillate, so we proceed to find the K value of the sustain using the Law's law. The formula is given by K1 equals to K saturated 1 divided by the pressure. In our case, it's 3 atn. So we start into formula and we find the K value of the ethane is 5.2566. And we're using the Law's law to find the K value of the propane, which is 0.7067. Okay, next, after finding K value of the propane and ethane, we substitute into the equation 13.0116, where is the summation of Zi times Ki over 1 plus V times Ki minus 1 equals to 1, where Zi is the molar fraction of the sustain in mixture, and Ki is the K value of the sustain, and the V is the molar fraction of the mixture that will be vaporized to vapor. Okay, after we calculate V1, which is mole of vapor, will equal to 0.4047 mole. And we know that sum of mole of vapor and sum of mole of vapor and the liquid will be equal to 1. So we use 1 minus mole of vapor, we get the mole of liquid is 0.5053 mole. And we further calculate the S1, which S1 is given the formula S1 equals to P minus P saturated 2 over P saturated 1 minus P saturated 2, and we get the value is 0.06447, and we further calculate S2 is 0.9355. So this means that in 0.5053 mole of liquid, they will contain about 6% of the ethane and 93.55% of the propane. And we further calculate Y1, which Y1 equals to K value times its mole fraction of the liquid, and we get the value is 0.3389, and Y2 equals to 0.6611. It also same meaning in 0.4347 mole of the vapor, we will contain about 33.89% of the ethane and about 66% of the propane.
Alright, so this is the TXY diagram and the PXY diagram. So when we are designing the flash distillation, this is not necessary, but it is very useful to determine whether your chosen temperature lies in the two-phase region, separation feasibility, and also to choose the right temperature over pressure for the flashing. This is useful to visualize the phase behavior of the ethane and propane mixture as well. So for the y-axis it is temperature in Kelvin, and for the x-axis it is xy and y1. Okay, so these are the safety issues when we are designing the ethane and propane flash distillations. So the first one is actually the flammability and explosion hazard, because they are extremely flammable gases and leaks may form explosive mixtures with the air. So in order to address a solution to this, we should install gas detectors, flame arresters, and proper ventilation. The second safety issue is overpressure and release. For rapid flashing of liquefied gases, there is large vapor expansion, and also for the risk of pressure built up in vessel or piping. And lastly, we should install pressure relief valves such as a PRV and rupture these. Okay, so this is our conclusion. So ethane at 20% and propane at 80% is as fit to the flash separator, and vapor and liquid are separated. So Y1, Y2, X1, X2 are clearly stated, as you can see. And by applying the Raoult's law and material balances, we demonstrated how efficient separation can be achieved in the two-phase region. Key safety aspects such as flammability, cryogenic risk, and overpressure were carefully considered to ensure a safe and reliable design. Thank you, Doctor, for attention. So we are from Group 6. Everybody did their own job very good, and thank you for attention.